Hey guys, so today I'm going to be covering chapter 13 in Paul Hewitt's Conceptual Physics book, which talks all about liquids. Hey guys, so as you can see, we have a giant poster board with chapter 13 liquids written at the top, and we have it broken into 5 different categories that we will discuss today. There is pressure, buoyancy, Archimedes' principle, floating versus sinking, and Pascal's principle. And we will discuss in detail all of the sections. So we will first discuss pressure. Pressure has 2 different ways to solve for it. Pressure is equal to force per unit area, which is this one. And pressure can also equal weight density times depth. So what this means is that the lower that you go in a liquid, the more pressure there will be. And the higher that you go in a liquid, the less pressure there will be. Now, let's suppose that we have a large aquarium that we are drawing here. And 2 men work in the aquarium, and they are told to clean the tank. One of them is cleaning at the top, and one of them is cleaning at the bottom. Which one will have more pressure on them? The man at the top or the man at the bottom? If you said the man at the bottom, then you are correct. One more thing that you should know about pressure is that no matter which one of these containers you have water in, if they are all filled to the same height, which they are, no matter the weird shape or size or whatever, as long as the water is filled to the same height, they will all have the same pressure. And that's a wrap on pressure. So now we will move on to buoyancy. So buoyancy is a force, therefore it will be measured in newtons. Just like gravity, buoyancy is a force, and we're familiar with gravity, which is a downward force. But buoyancy is kind of the opposite. It is an upward force. Now, we all know that whenever we place a box on the ground, it's going to have gravity acting on it. But what happens when we place the same box in a tank of water? We know that gravity is of course acting on it, as always, but there's also a buoyant force acting on it. And that's pretty much the simplest part. That is the simplest part about buoyancy. We will discuss more in a moment. Principle. Archimedes' principle states that an immersed object is buoyed up by a force equal to the weight of the fluid it displaces. Now, this might sound a little bit confusing, but don't worry, we're going to explain it. So here we have a little gingerbread boy that we're drawing, and as you can see, he has blocks. Little gingerbread boy likes to play with blocks in the bathtub. He has little blocks and he has big blocks. We're gonna draw a tub with the little block and the big block right next to each other in it. And I want you to try to guess which one is going to have more buoyant force. If you said that it was the big one, then you are correct. Why is this? The answer is volume. So, more volume is equal to more buoyant force. The big one, the big block, has a larger volume, therefore it is pushing away more water than the little block would. And that covers Archimedes' principle. Next, we're going to cover floating versus sinking. Basically, what makes an object float and what makes it sink. So we're going to go back and visit our friend density. As we remember, density is equal to mass divided by volume. Now, we're going to take a moment to look at these 3 things. If the density of the water is greater than the density of the object, then it is going to float. If the density of the water is less than the density of the object, then the object is going to sink. If the density of the water is equal to the density of the object, then it'll find a happy middle. That covers pretty much everything for floating versus sinking. And so now we will move on. Now we're going to cover Pascal's principle, which is the final thing in our board. Pascal's principle states that a change in pressure at any point in an enclosed fluid at rest is transmitted undiminished to all points in the fluid. Now, 1 Pascal is equal to 1 Newton per meter squared. Pascals are actually the SI unit used for pressure. Now, pressure, as we remember from the top, pressure equals force over area, sorry. So let's solve this problem. We have a large thing which has water here, water here, water here. Now, as we can see, the opening here is much larger than the opening here. So right here, the area is 1. And then the area here is 50 times that area. We know that this is 10 kilograms pushing downwards on the water. And we know that this is X, which is what we would like to find. Now, we know that pressure has to equal pressure due to Pascal's principle. So pressure is equal to pressure. Therefore, we're going to use force over area equals force over area. So we know that the force is 10 to 1, and then we're trying to find X to 50. So whenever you cross multiply, then you will know that X equals 500. And that pretty much covers Pascal's principle. So if you're ever feeling like physics is really hard, then just break it down, because Pascal doesn't think it's that hard.